Okay, so on this question, they give us a graph and then they give us a function. I guess that's the function f of x that they're giving us right here, giving us the equation in the picture. And they're saying find f prime or estimate f prime using h as 0.001 for the following value, f prime and a to 2.75. There's the answer. How did we get it? Well, basically, when it says estimate f prime, what is f prime? That means the derivative or slope at one point. So we mean right 2.8, 2.75, where that's about, I don't know, about right there, right? Because here's -2, here's -3, so -2.75 is about right there. So okay, and on the curve. And then we want to know the slope there. Like how steep is the graph right there? Like, I mean, I can eyeball it. It sort of like that, like that looks like the tangent line that hits the curve at just that one point. That's what we want. We want to know what is the slope of that line that hits the curve at just that one point. Slope of the tangent line derivative, that's what f prime means. It's the slope of that line. What is the slope? What is the derivative or the slope of it? In other words, that if you were riding a roller coaster, and coming down the curve here, it means right at that one point, what would be your slope right at that one point? What's the slope of the tangent line? That's what we're trying to find. Okay. Well, we're going to estimate it. How do you estimate it? Well, the reason we're saying estimate is because to find a slope, you know the slope formula, right? The slope formula is y2 minus y1 over x2 minus x1. It's rise, right over here. It's rise over run. Rise over run. You know slope is rise over run. So that means we need 2 points. So let's do this. Let's pick a second point anywhere you want. Well, we'll say that's a second point there. And then we'll connect those 2 points with a line. And we'll find the slope between those 2 points. This point right here, we're going to call this point x, f of x, because f of x is the same as y. You with me on that? Right? F of x of function values on a graph always mean y values. F of x, g of x, h of x, whatever you want to call it. Function values are y values. That's by common agreement in the math science world. So now this is a second point. What is the coordinates of this point? Well, what we're going to do, I don't mean I'm going to actually look down here and find out what its coordinates are. I'm just going to say, hey, it's a little bit to the right. In fact, actually, let me make it a lot closer. Let me make it just right there. So in other words, I'm going to say it's only x plus a little bit. That h is our way of saying a little bit. X, it's just a little bit to the right of x. And the height of it, of course, is f of x plus h. Is that of course? Does that make sense? Because whenever you have an x value, even if it's x plus h or you call it Joe, whatever you want to, x plus h is just a name, then f of that is the height there. It's the y value there. So this here is y1, this here is y2. This here's x1. Here, let me change my color. This will be y2. I'm not doing that so well. This whole thing is x2. You with me? So what we're doing, we're trying to come up with a formula right now for how you can find the slope between these 2 points. And so the way that, and we're the first point is just any point over x up f of x. The second point is a little to the right, x plus h, a little bit to the right. H is a little bit to the right, and f of that. So the slope then between those two, slope is going to be, it's going to be f it's y2. So it's f of x plus h, right? That's y2 minus y1. It's y1 f of x all over x2 on the bottom, x2. What's x2? X plus h minus x1. What's x1? X. So let's simplify that. Oh, and the slope at just the 1 point is, we'll put a shake equal sign. That means approximately, I'm getting a little scribbly there, approximately, approximately equal to f of x plus h minus f of x. And these x's will cancel over h. There is our formula. We're going to use that formula to estimate f prime, the slope, and it tells us what h to use, the little bit to use. So there's the formula we're going to use. All that was just derivation. You don't have to do all that. You just have to use this formula. I just wanted to show you where the formula comes from. Let's now use the formula. So here we go, coming on down. I'm going to use that formula. So first off, it's going to equal f of x plus h. Well, what is x? This is x, negative 2.75. That's the x value. Oops, right there. So there's the x value. So f of x plus h means f of negative 2.75 plus h, and h is right here, 0.001 minus f of x, again, that's f of negative 2.75. Extend my line a little bit here. Over what goes on the bottom is just h. Okay, so now try another step. What is f of that? Well, that means plug all that in for x. There's the function right there. So that's going to be 7 times 0.8. You don't need that. Well, if you want the 0, that's fine. I'll do it. 0.8 to the power negative 2.75 plus 0.001 minus, and then you just plug it in again. 7 times 0.8 to the power negative 2.75 all over h. But what is h? 001. There it is. That's what we're going to have to type into Desmos. That is going to be f of, that is f of x plus h, this is x, this is h, minus f of x, all over h, which is 0.001. So type that into that, and that'll be what? And that'll be an estimate of the slope right here. Do you see why it is? Because we took 2 points, 1 point just a little bit to the right of the second point, and we did the formula y2 minus y1 over x2 minus x1, right? And we simplified it, and then we plugged in. And the fact that these are really close together means that it's going to be really close to the same slope that just exists at 1 point. That's why it's an estimate for the slope at 1 point, which is called the derivative or the slope of the tangent line. All right. Anyway, long story short, type that into Desmos. I'll show you. You have access to Desmos during exams and everything else. Here it is. I typed it into Desmos right there. See how I use the parentheses and type that in real carefully? There's our answer. Negative 2.8849. See how that comes out? So I can show it typing in again. Got to hit the fraction button, then 7 times, then I do the 0.8. You don't have to have the 0 on the front, but then you got to go to the power, the A to the B power button, and then parentheses, and just keep typing. There it is, 2.8849. So is that the answer they got? Indeed, it is right there. 2.88, negative 2.8849, blah, 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 blah. That is an estimate for the slope at this one point, what we call f prime. See the prime there? F prime at negative 2.75. The slope of this curve right at the point negative 2.75 as if you're headed on the roller coaster, what's your slope right at that instant? We estimated it by taking a point just a little bit to the right, finding the slope between those 2 points, and that's what we got.